Hi guys, it is the day 1-8 notes, and it's talking all about the angle and side relationships in triangles. And the nice thing is you can visually look at them and understand the relationship. So the first rule here is talking about the length of the side is compared to the angle across from it. So the largest side is always opposite or across from the largest angle. The shortest side or the smallest side is always opposite the smallest angle. So when you look at it, if that's my smallest angle, then directly opposite of it, that should be the shortest side, all right? And same goes for if that's my biggest angle, then opposite that should be the biggest side or the longest side, all right? So it says, what is the longest side of triangle ABC? Well, then that would be side AC right here, and you can put the bar over it or not. That's up to you. And then what is the smallest side of triangle ABC? That's going to be side AB. All right. So when it says in triangle RST, this first example here, let me slide down just a smidge. We have angle R is 58 degrees, angle S is 72 degrees. Order the sides from smallest to largest. I do think it helps just to give yourself a diagram. Diagram doesn't need to be drawn to scale, just so that you can kind of see the triangle itself. So if angle R is 58 degrees, angle S is 72 degrees. To be able to truly answer this, you need to know all three angles. So take a moment and use the triangle sum property and add up 58 and 72, and that'll give us 130 degrees. And then when we subtract that from 180, that's going to leave us with 50. Now that we know all three angle measures, now it's easier to say what's the smallest, what's the longest, and so on. So since we're going to go smallest to largest, smallest angle, there's my smallest side. So that's going to be RS or SR. You can say it either way. The next biggest angle is 58. So across from that, I'll call it my medium length side. That's going to be ST. And then largest angle. So this should be the largest side, and that is RT. Don't worry about TR versus RT. You're referencing the same side, so it's perfectly fine. When you look at the next ones, similar, but kind of in reverse. So in triangle ABC, so give yourself a little triangle to work with here. AC is 3, CB is 4, AB is 5. What is the smallest angle of the triangle? So here's my shortest side. Go directly opposite of that. It's going to be angle B. So I don't really know what the measure itself is just yet. There are ways to do that, but we're not talking about that yet. But I at least know which one's going to be the smallest. All right, go ahead and flip it right on over to the next page. Then we extend the idea of what we're talking about here a little bit. It says, as shown in the diagram below, side AS right here is a diagonal of trapezoid star, so STAR, where RA and ST are parallel. Angle ATS is 48, angle RSA is 47, and angle ARS is 68. So everything's labeled in there for you, even if you can't see it that well on the video here. It says determine and state the longest side of triangle SAT down here. So we want to be able to find all the angle measures. That's our goal. All right, in triangle SAT. So right now we know one of them. The fact that they're telling us the lines are parallel means we need to use that property. So if I think about it, parallel lines, I can see with that diagonal, that Z shape right here, kind of popping on up, means that we have some alternate interior angles. So whatever this angle is, that angle is going to be. So let's do some work up top. The fact that we have 68 and 47 in this triangle here means if we add 68 and 47 together, I get 115. So if I do 180 minus 115, that's going to leave me with 65 degrees. So how that helps me out is once I know this is 65, then its alternate interior has to be 65. And so we've got 48 degrees, 65 degrees. Let's now get that top angle up here. Right, so you have some space below, or you can do the work above, doesn't matter. So 65 and 48, that's going to give me 113 degrees. If I then subtract that from 180, I'm left with 67. So now that I have all three angles in that triangle, so I've got 65, 67, 48. It's asking which one is the longest side of triangle SAT. So that's going to be across from my 67-degree angle. So that's the side down at the bottom, which in the picture is this right here, side ST. Now, when it says justify your answer, doesn't necessarily mean an explanation. You can explain it. You could write out a sentence. Otherwise, justification is the actual algebraic work that you're showing. So you can't just pick a side and have no work to support it. If you have some work done around it that supports your answer, that is your justification. All right. Down at the bottom, in triangle ABC, angle A, angle B, and angle C are all given by expressions with X. Order the sides of triangle ABC from smallest to biggest. All right, give yourself a little space here. So triangle ABC, A is 12x minus 2, B is 14x minus 3, C is 10x plus 5. All right, before we can answer anything to do with this, we need to know what the angle measures are, same as last time. So the fact that we have three of them, and we know that all the angles in a triangle add up to 180, that's where we need to start this problem. Add all of these guys up, set them equal to 180 degrees. All right, let's start cleaning things up. 12x, 14x, 10x, that's going to be 26, 36x. We have minus 2, minus 3, and plus 5, which are going to balance each other right out to 0. So we can ignore it and just set it equal to 180. If we divide by 36, 180 divided by 36, we're left with x equals 5. And it always feels good when we get a nice, pretty answer here. All right, from here, now let's plug back in. So each angle, angle A is 12 times 5 minus 2. 12 times 5 is going to be 60 minus 2. That'll leave us with 58 degrees. So I can come on over here and put that 58. Angle B is 14 times 5 and then minus 3. So 14 times 5 is 70. Minus 3 will leave us with 67. Finally, angle C, 10 times 5, that's 50. And then add 5 to it, we get 55. All right, so let me kind of get my labels in here. All right. Go back and reread the question. Order the sides from smallest to largest. So smallest angle, locate that first. That's my angle C. So the side opposite of it, that's my smallest side. So that's going to be AC. Find your medium angle. That's my 58. Go across from that. That's going to be side BC. And then lastly, biggest angle, biggest side. That's going to be side. Oops. I just realized I wrote it wrong. That should be side AC. So my first one should have been side AB. I'm not sure if I wrote it wrong or said it wrong. So let me clarify that. So AB, BC, AC. That should be the answer from smallest to biggest. All right. I like that question. It's a lot of work, but I like that if you one step at a time, you get all the way through it. All right, let's keep going. For the next page, classifying triangles by angles and sides. All of these terms should be familiar to you from previous years of math. So classifying the triangle by its angles can be acute triangles, equiangular, which is a little tricky to say, right triangles, or obtuse triangles. All right. With an acute triangle, that means that all three angles are acute, which we know means less than 90. If it's equiangular, that equi part of it means that all the angles are equal. And for them to be equal, we would have to divide up 183 ways. They all have to be 60 degrees. So 60, 60, and 60. All right. For a right triangle, obviously it means that there's a right angle, but it can simply contain only one right angle. And then same goes for an obtuse triangle. Not that it contains a right angle, but it contains one obtuse angle. And just to clarify, right angle meaning it's 90, obtuse angle meaning it's between 90 and 180 degrees. So greater than 90, but less than 180, all right? So let's take a look here. When it says classify each triangle by the angle measures, make sure to look at all three because it matters, right? That all three are maybe acute for it to be acute and so on. So for triangle FHG, I'm just going to outline that. FHG. All right. If I look in the picture, two of them are 60, which if I have 60 and 60, it's going to force that last angle to be 60 because this would be 120. Subtract that from 180. Yeah, it's got to be 60 degrees. So even though it's acute, I would want to classify it as specific as I can. And so that first one, I would want to qualify as equiangular. So acute's not wrong. It's just not the best description, right? The most specific description. All right, EFH. That's the one next to it here. So if we look at EFH, I can see two angles. I can't see the third one, so we're going to have to calculate the third one. So this angle right here, I can either calculate by adding up 30 and 30 and subtracting from 180, or using the fact that these two make a straight line together and therefore are supplementary. Either way, if I go 180 minus that 60, it's going to leave me with 120 right here, which is an obtuse angle. So this should be an obtuse triangle. And then triangle EHF, EHG, excuse me, EHG. That's the big triangle right here. All right, if you look at the corners, we got 30 over here, 60 here, and a total of 90 there. So that means we are looking at a right triangle. Perfect. All right. We have one last page to take a look at. When you flip it on over here, the classifications on this page are specific to the side measures. So last ones were specific to the angle measures. These are talking about the sides. So when we say equilateral, yes, it goes hand in hand with equiangular, but specifically what it means is that all three sides are equal, or you can say are congruent. So in the picture, I want you to mark that the sides are congruent here. Right? If you'd like to write also equiangular, sure. Isosceles triangle means two sides are congruent. And you can use congruent or equal in this case. Does not matter. All right. What we should note is that also the base angles are equal as well. So what does that mean? This at the bottom, the side that's not equal to the other two is considered the base, and those are the base angles. So extra little info, something you might have known in case you forgot about it. Now you know. Scalene triangle, no sides are congruent, or no sides are equal. So to show that, you could show a single swipe on one, two swipes on the other, three on the last one. So you're just showing that they are all different from one another. So the last examples we have to look at are just some practice with that. So classifying each triangle by the side lengths. So look at those little notations. So triangle EHF, if I look here, this one has one slash on it, has 10. This has a slash on it, so that's also 10. So I've got 10, 10, and 12. So two equal sides. That's an isosceles triangle. And then triangle EHG. So EHG. All right, you've got 12, you've got 11, and then this whole side together, 14. Answer that question right there. That's your post question. All right. Last thing, you've got triangle ABC. AB is congruent to BC. You're given a bunch of measurements and it asks you to find the length of each side of the triangle. All right. Let's draw it. So because it says AB is congruent to BC, I kind of just like those ones to be the congruent ones. So I'm going to label it that way. If you labeled it already, then mark whatever sides are congruent. AB is 5x, BC is 2x plus 18, and AC 6x plus 4. Now it's really important to note they are not angle measurements. You are not going to add them up and set them equal to 180. Instead, we're going to use the sides that we know are congruent and set them equal. And for right now, we're going to ignore this side at the bottom. So just pretend it's not even there. All right. So if we set AB equal to BC, that means that 5x equals 2x plus 18. Go ahead and shift that on over by subtracting 2x out, and then divide. Once you know what x is, now we can plug that in for all three sides. So AB is 5 times 6, or 30. BC should be the same thing, but you could absolutely solve and kind of just check. So that would be 12 plus 18, so that checks on out. And then AC, if we do 6 times 6 and then add 4, that's going to give us 36 plus 4, or 40. So this is a great question where you could ask an extension even. So I could ask you, what is the largest angle in the triangle? And you should be able to tell me. So post question, what is the largest angle based on what we came up with? So you got a two-parter. You got 1B right here, and then you've got 2 with a little addition. All right, make sure to answer those as soon as you end the video here. Thanks, guys. See you later.